Welcome everyone. We are the Polimi Space team, here to present you Moonsweep, our proposal for the 2020 ActInSpace hackathon. Today, the market for Earth imaging and data processing is growing at an unprecedented rate. The very complex network of Earth and space-based assets lets us see our planet in ever-increasing detail. Now, let's imagine the year 2025. A new moon race is taking place, and this time private companies will play key roles in creating lunar infrastructures. In this new lunar economy, geographical, topological, and geological information will be crucial in order to face the harsh environment. Our goal is to collect, process, and provide these informations in a clear way to our customers. This will favor a safer and more aware development of human activities on the moon. Let's look at a more detailed view with an example. This is a mock-up of the user interface of Moonsweep. The client of our example is looking to build a solar power plant on the moon. He selects the desired activity he wants to establish. Then he can choose what resources are needed for the construction and for the operations of the building. The software will provide suggestions based on construction resources looking up templates. Note that resources can be either in situ and must be processed, or provided by a supplier. At last, the user will select a maximum risk level. He will also be able to change individual risk settings, weighing the types of risks as he prefers. After the user's query, the software will start a search for locations that satisfy the construction requirements while minimizing a cost function, which depends on quality and risk parameters. In this example, we can see a possible site near the Shackleton crater on the South Pole. The best options are returned to the user. He can now consult the analysis of both quality and risk. In quality analysis, he will see details about availability of resources, both in situ or supplied, and how easily they can be reached. A reachability rating will be displayed. It considers both transportation infrastructure and roving vehicles. In the risk analysis, instead, the customer will be able to understand what major risks are related to his activity on this site. These are divided in risks that cause a major failure in the plant and risks that undermine its operability, such as a failure in telecommunication, in the supply chain, in transportation, and so on. Note that operability risks are lowered when a diversification of the resources is present. As our business model, we aim to offer different solutions to different customers. In the case of private companies, we could give the relevant information about risk-rewards perspectives. Then, incrementally broader sets of information can be supplied to insurance businesses. Space agencies and governments could buy the most complete assessment of resources. These can be used to invest in further infrastructure, thus enabling the moon economy to fully develop and mature. So, we've seen how we can process the data on the moon's surface. However, the question still stands. Where can we get this data from? The process of data retrieval will scale up with Moonsweep. In the first phases of development, already existing informations will be used. In this image, we can see data retrieved by already existing satellites. These informations are a good starting point, but they aren't complete. Data may be unavailable or of low quality for certain areas of the moon, especially the poles. In some situations, this can be improved with machine learning algorithms. More importantly, the available dataset grows really slowly in time. This doesn't favor the growth of the software capabilities. This brings us to the second part of our scaling up strategy, the deployment of a small constellation of moon-observing CubeSats. In the video, you can see a fleet of 13 6U satellites, which can all be carried as auxiliary cargo by an Artemis mission or commercial providers. They orbit in frozen polar orbits. The moon's surface can be completely mapped in high resolution about every 2 days. This gives an abundance of new data and also a quasi-live view of the lunar activities at the poles. The last step is intended to link the information gathered from orbit with the composition of ground samples. By deploying a fleet of regolith scanning rovers, a very detailed map of the lunar soil and minerals can be extrapolated. This allows us to expand even more the capabilities of Moonsweep. Thank you for your attention. If you have any further questions, you can mail us at any time. As a final note, this is the Moonsweep core team. We are all colleagues at the Space Engineering Masterclass at Polimi. We are also looking at including new team members. This wouldn't just broaden the team's expertise in other fields, such as AI, geology, and business. It would also help in getting a broader set of social backgrounds and experiences.